So let's simplify this complex fraction, or in some of the literature within our Lumen OHM, you may see that it's called a compound fraction, right? But let's simplify it using the LCD, the least common multiple of the denominators. The LCD for 7, 2, and 4 is 28. Now, there are a few ways you can go about finding the LCD. If you were to list multiples of, let's say, the largest two of the three denominators of the 7 and the 4, right? Multiples of 7. 7, 14, 21, 28, 35, and so on and so on, all right? Multiples of 4, 4, 8, 12, 16, 20, 24, 28. We can stop here since we have found the least common multiple for 7 and 4. As long as we can show and confirm that 2 divides into 28 evenly or exactly, then the 28 is our LCD. Now, you can also use the ladder method or the prime factorization step method to list the prime factors of 7 and 4 and then build that LCD using 7 times 2 times 2, and of course we get 28. Right, so just some examples. So the LCD is 28. We're going to use the 28 to clear the denominators in both the numerator and the denominator, which means we take 28 and we're going to multiply it times the 1 over 7. 28 times 1 over 2. 28 times 1 over 7, and 28 times 1 over 4. What this will allow us to do is it will allow us to see how the denominators of each of these fractions in the top and the bottom, how they cancel out into that LCD. So here we go. 7 will divide into 28, and that leaves 4. And 4 times 4 is 4. 4 times 1 is 1. The 2 will divide into 28, 14. And that leaves us with 14 times 1, so we bring down the 14. So now our numerator has changed from fractions to simply 4 plus 14. Now let's look at the denominators. 7 divides into 28, leaving a 4, and we multiply 4 times 1, and that's 4. And then lastly, 4 divides into 28, and that leaves a 7 here, and 7 times 1 is 7. So we have converted each of our fractions to whole numbers using the multiplication of the LCD. So now we end up with 4 plus 14, which is 18 over 4 plus 7, and that's 11. So 18/11 is our answer. Now, let's examine a different one. Let's say that we have a complex fraction where we have variable terms, right? So you see the difference here. We have 2x over 7 plus 1/2 divided by 1 over 7 plus 3x over 4. We're going to use that same process. We will be using the LCD in order to clear the denominators to simplify this complex fraction. So we still have the same denominators. We have 7, 2, 7, and 4. So our LCD is still 28. So we're going to take 28, multiply it times each of the terms in both the numerator and the denominator. So that means 4 separate times. And let's watch what happens to each of the terms, right? So the denominators will divide directly into that LCD. 7 divides into 28. That leaves a 4. And 4 times 2x is 8x. And then we divide 2 into 28, and that leaves us with 14 times 1 here. and that changes to a 14. Now we'll go in the denominator. 7 divided into 28 will leave 4, and 4 times 1 is 4. And then lastly, we have 4 divides into 28, which leaves 7, and 7 times 3x is 21x. Now we will want to make sure this is the correct answer, all right? This is our final answer. However, we always talk about making sure that we factor our rational expressions as much as possible to ensure that there's no way to simplify, right? So in the numerator, we can factor this. We have an 8x plus 14. There's a GCF of 2. So if I factor out the 2, then that leaves me with 4x plus 7. Right, 2 times 4x plus 7. But the thing is, after factoring that numerator, there's nothing that's going to cancel out. So that's why I was saying a moment ago that the 8x plus 14 over 4 plus 21x is the correct answer. If we were to factor a little bit more, we see that there's nothing that's going to simplify, so we can actually use either of these as our answer.